Hi guys, welcome to lesson 7-11. This lesson's on decomposition of partial fractions. And first of all, pardon my voice. I'm still getting over getting sick, so hopefully you can understand what I'm saying. Decomposition of partial fractions, what is it? Sounds super complicated and fancy, but it's really not. Okay, so you don't need to write this part down. I'll just kind of go through an example of a process here, and then we'll talk about what the actual decomposition part is. So it says, consider the problem of adding two fractions. We know that if we wanted to add these two fractions together, we'd have to look at each of the denominators, right? You have to have a common denominator between them. So we know that that common denominator would be x plus 4 times x minus 3. Right? So we would have to take it here, and if we were doing it as in two steps, you could say this would be like 2 times the quantity of x minus 3 over an x plus 4 times x minus 3, right? I multiplied my first fraction by the x minus 3 over x minus 3. Then the second one would have been 2 times the quantity of x plus 4 over that same denominator. Right, and that would allow us then to rewrite it as one fraction, right? So we could say here that this would be, I'm going to go ahead and distribute this through, make it 2x minus 6 plus 2x plus 8, right? I'm just simplifying my numerators over just that single x plus 4 times x minus 3, and then we would just combine our like terms. We'd have 4x plus 2 over x plus 4 times the quantity of x minus 3, right? That would be our answer. Okay, so that's when we're adding two fractions together. So what we're going to look at here today is the decomposition of partial fractions, which is simply taking our answer from this problem and going backwards and breaking it apart into smaller pieces. Okay, so we're doing like the opposite process. And this is something that will be used more in calculus, so it's something we want to make sure you know now before you get to calculus. So our first example, we'll go through 3 examples here. Hopefully that'll be enough for you guys, and then you can practice. Remember, since it's a video, you can always pause it, rewind it, watch it again, do what you need to do to make sure that you're understanding. I'll be back hopefully next week, and then I'll answer any questions that you have. So starting out here with the 8x plus 7 over x squared plus x minus 2, let's take our denominator first and let's factor whatever we can. Right, in this case, we're going to have 8x plus 7, right? When I factor that denominator, it should be x plus 2 times an x minus 1. Okay, so we haven't really changed the value of anything here. We just want to figure out here what over x plus 2 plus what over x minus 1 will give us this as an answer. Or we could say this since that's in the factored form. So we don't know what that is right now. So we're going to call these missing expressions A and B. Okay, now if we treat this like that original problem from the front slide here, right? Talking about this one right here, okay? If I wanted to add them together, we would just do the same process we did on that one, right? We need a common denominator. So we'd have to multiply this first fraction by an x minus 1 over an x minus 1. So we've got a times the quantity of x minus 1 over x plus 2 times an x minus 1. And then our fraction with the b on the top, right, we need to multiply by an x plus 2 on the top and bottom. So we now have common denominator, which would then allow us to rewrite this as one fraction. So as I do it here, I'm going to go ahead and distribute my a through this quantity, and I'm going to distribute my b through this quantity at the same time. as I'm rewriting it as one fraction. So that should be ax minus a plus bx plus 2b all over x plus 2 times an x minus 1. All right, so now let's just focus on just the numerator for a moment. Okay, so I'm focusing on just the numerator right now. So we've got this piece of it here, this ax minus a plus bx plus 2b, right? That's what we're focused on. Okay, let's go ahead here and let's just rearrange that to get our x terms together. So we have ax plus bx, and that looks like we have a minus a and then plus a 2b. And what we'll need to do now is let's factor by grouping. Okay, that's why it's important that you know that skill, because you're going to use it in this one. So in this case here, I'm going to just think about my grouping, right? So I have an ax plus bx. I'm going to say plus, and then I'm going to have a negative a plus 2b in that second set of parentheses. Okay, so what's that going to do for me? Well, it's going to allow me to factor out this x. So as we do that, we've got x times the quantity of a plus b, and then I still have that plus a negative a plus 2b. All right, so this, right, is our numerator. We just said this was our numerator. Well, I want you to look at our original numerator that we started with, 8x plus 7, right, because this expression needs to equal 8x plus 7. So if that's the case, right, we can see where the x comes from, right? Our x shows up right here, or you can think about this as a plus b, right, times x, and then we have plus, our negative a plus 2b. Well, this part of it right here has got to end up equaling 8. So we can take that and say a plus b must equal 8, right? This has to equal 8 because that's the coefficient of the x. And then this part here in the back, right, we know has to equal a positive 7. So that's going to give us a negative a plus 2b, we know equals 7. And now we have a system of equations that we could solve. Right, so and it's really nice on this one because it's already set up for elimination. Right, we could use elimination right here. I'm just writing it in case some of you don't have earbuds and you're just watching it. Okay, so we add the left side together. We've got 3b is equal to 15. We divide each side by 3. We're going to get that b is equal to 5. And then now that we know that b is equal to 5, we can solve for a. A plus 5 is equal to 8. Therefore, a has to equal 3. Now, what do we do with that information? Well, remember, we were trying to get this into this form here. So now that we're just looking for our a and our b, we're just going to substitute those values in. So we're going to say our answer would be 3 over x plus 2 plus 5 over x minus 1. And just like that, we're finished. And if you weren't sure if that's right or wrong, you could always take it here and add those two fractions together by getting a common denominator. And when it simplifies, it should get you to our original problem. All right, let's go to the next one. Ooh, this one only has. Okay, now on to the second example. You'll see with this one we have x over x squared minus 5x plus 6. Nothing changes here. We're going to go ahead and follow the same process. You can think of x as being like an x plus 0, or even like a 1x plus 0, if you're just trying to think about the values of different parts. but we still need to factor the denominator. So in this case, we should have an x minus 3 times an x minus 2. Okay, so our goal here will be to rewrite this fraction above as something over x minus 3 plus something over x minus 2. That's our goal. So we'll call this missing part A and B for each of those fractions. Okay, so the next part, remember, just getting the common denominator, multiplying the left fraction by x minus 2 over x minus 2. So I have A times the quantity of x minus 2 over x minus 3 times the quantity of x minus 2 plus B times the quantity of x minus 3 over x minus 3 times x minus 2. And again, I'm going to simplify my numerators as I rewrite it as one fraction. This would be ax minus 2a plus bx minus 3b all over x minus 3 times x minus 2. Okay, so remember that next part here is the one where we're going to just focus on just the numerator for the moment. Okay, so let's take it, let's recopy it, ax minus 2a plus bx minus 3b. Now we're going to factor by grouping, right? So when I do this, I'm going to rearrange them first. We're going to say this is ax plus bx, and then I want to say plus, I should have a negative 2a minus 3b in that second group. Okay, so we can factor out our x, and in this case we have a plus b times an x, and then we have plus negative 2a minus 3b in the second set there. Well, hopefully you can see what this should equal, right? This should equal like our x, right? Because remember, our a plus b should end up equaling 1, so we can go ahead and even write that. We have a plus b equals 1, and then we've got negative 2a minus 3b, right, should end up equaling our 0. And now we'll just work on solving this system. So if it's me, I would actually just take it and multiply the top by 2. So we're looking at what, 2a plus 2b is equal to 2. Actually, I guess I didn't need that in there. Let me get rid of it real quick. Right, and then we'll just redraw it below. So a's are going to eliminate. We're going to have a negative b left over is equal to 2, which means that b should equal negative 2. And then we are going to need to go back and figure out what a is. So if we know that a plus b is equal to 1, we know that a plus negative 2 equals 1, and therefore a has to equal 3. All right, so now that we know that our a is 3 and our b is negative 2, we can take it and substitute it back into this expression to get our answer. We should have, for this problem, 3 over x minus 3 plus negative 2 over x minus 2. Or remember, you could always write it this way as well. Both are acceptable. All right, there's one more. Let's go ahead and jump into it. We have 7x squared plus 18x minus 1 over x squared minus 1 times the quantity of x plus 2. Okay, looks good here. If we were going to take this and factor our denominator, right, we'd actually have 3 terms down there. We'd have an x plus 1, an x minus 1, and an x plus 2. So as we look to break that apart, right, we're going to want to have something like a over x plus 1 plus b over x minus 1, And then we'd say plus c over x plus 2. Okay, so this one might get a little longer. So if you need more space, you can always, go onto another sheet or look at the back side of the paper if you need to. Okay, so in order to get a common denominator here, right, I'm going to have to multiply this first fraction, right, by the x minus 1 and x plus 2 in the top and the bottom. So I have an a times an x minus 1 times an x plus 2. And then we're going to have plus b times, and b would need to be multiplied by these two. So we have x plus 1 times x plus 2. And then lastly, we would have to have c times x plus 1 times x minus 1. Okay, so really this is all over x plus 1 times x minus 1 times x plus 2. Okay, but we're still going to go through that same process we've been doing, so we need to simplify everything. So when I look at my numerator, I have a times an x squared plus x. Minus 2. For b, we've got it being times x squared plus 3x plus 2. And then for c, we've got times x squared minus 1. Now let's go ahead and simplify that all the way by distributing your a through. Ax squared plus ax minus 2a, bx squared plus 3bx plus 2b, and then finally our cx squared minus c. So that's a pretty long expression. Hopefully you're keeping up. Remember, you can always pause the video, fast forward, rewind, do what you need to do. All right, so what we're going to do next here then is we are going to rearrange these terms, right? I'm going to go ahead and put like all of my x squared terms together. Okay, so we'd say ax squared plus bx squared plus cx squared. I'm just doing to make sure I don't overlook any. And then any of our x terms, we have an ax and a 3bx. And then we have minus 2a plus 2b minus c. Okay, so nice and long there, but right, we're going to break this down and factor it into smaller pieces. So if I factor out x squared, I have a plus b plus c times x squared. And then I've got plus, if I factor out my x here, I'm going to have a plus 3b times x. Hopefully you guys are seeing where that's all coming from, right? Right, there's this one. This is kind of like our second group here that has the x's in it. And our third group, really, we're just going to keep it all together. I'm going to say plus, and this would just be negative 2a plus 2b minus c. All right, so now as you look at that, right, you can compare that to this, right? You've got a plus b plus c should equal 7. A plus 3b should equal 18. And then negative 2a plus 2b minus c should equal negative 1. So let's get those jotted down, and then we can finish this. So a plus b plus c is equal to 7. A plus 3b is equal to 18. And then we've got negative 2a plus 2b minus c is going to equal negative 1. And now you just have your system that you need to solve. So I'm probably going to do elimination between the first and the third one, right? If we do between these two, we've got a plus b plus c equals 7, negative 2a plus 2b minus c equals negative 1, right? Add those together, you've got a plus 3b is equal to 6. Oh, did I leave a sign off there somewhere? Hold on, 3b. This is a negative a. There we go. So negative a plus 3b equals 6. Okay, and then let's go ahead and do elimination there, right? We'll use this one. We're going to move it over here. We've got a plus 3b is equal to 18. Those eliminate. 6b is equal to 24. So b is equal to 4. All right, plug that back in, figure out what a is. Right, a plus 3 times 4 is equal to 18. So it looks like a is equal to 6. And then 6 plus 4 is 10. So it looks like c is going to equal negative 3. And you've made it to the end, and so have I. So it looks like we can we can finish up here. Remember, you're writing it in this form. You're just plugging in your values. So a is 6. So we have 6 over x plus 1 plus 4 over x minus 1. And then instead of plus, right, because c is negative, we're going to say minus 3 over x plus 2. And that's it. So hopefully that makes sense. If you have questions, reach out, do what you need to do. I appreciate you watching, appreciate you working hard when I'm not there. And I will hopefully talk to you soon and hopefully see you next week.